Astronomers were initially baffled when they spotted a star 16,300 light-years from our Sun being flung back and forwards at speeds of several hundred miles per hour. They later found this extraordinary movement was in fact caused by a lonely black hole, 4 times the mass of the Sun, hiding in a globular star cluster. This remarkable discovery is the first time scientists have spotted a stellar mass black hole in a star cluster by detecting its gravitational pull on another object. Scroll down for video. The observations of the NGC 3201 globular star cluster were made using the MUSE, multi-unit spectroscopic explorer, instrument on the European Southern Observatory's Very Large Telescope in Chile. This particular cluster is situated in the southern constellation of Vela. Researchers were drawn to the star cluster when they noticed one of the stars behaving erratically. The star was being flung backwards and forwards at speeds of several 100,000 kilometers per hour, with the pattern repeating every 167 days, according to a statement Wednesday by ESO. It was orbiting something that was completely invisible, which had a mass more than 4 times the Sun. This could only be a black hole, said lead author Benjamin Geisers from Georg August Universität in Göttingen. The first one found in a globular cluster by directly observing its gravitational pull, he said. Globular star clusters are huge spheres of tens of thousands of stars that orbit most galaxies. They are among the oldest known stellar systems in the universe and date back to near the beginning of the galaxy. More than 150 are currently known to belong to the Milky Way. The relationship between black holes and globular clusters is an important but mysterious one. Because of their large masses and great ages, these clusters are thought to have produced a large number of stellar mass black holes. This happens when massive stars within them explode and collapse over the long lifetime of the cluster. ESO's MUSE instrument provides astronomers with a unique opportunity to measure the motions of thousands of faraway stars at the same time. With this new finding, the team have for the first time been able to detect an inactive black hole at the heart of the globular clusteron that is not currently swallowing matter and is not surrounded by a glowing disk of gas. They could estimate the black hole's mass through the movements of a star caught up in its enormous gravitational pull. From its observed properties, the star was determined to be about 0.8 times the mass of our Sun, and the mass of its mysterious counterpart was calculated at around 4.36 times the Sun's mass, almost certainly a black hole. Until recently, it was assumed that almost all black holes would disappear from globular clusters after a short time and that systems like this should not even exist, said Dr. Geisers. But clearly this is not the case. Our discovery is the first direct detection of the gravitational effects of a stellar mass black hole in a globular cluster. This finding helps in understanding the formation of globular clusters and the evolution of black holes and binary systems, vital in the context of understanding gravitational wave sources, he said.